Welcome to another episode of Curious Golang. In this episode of Curious Golang, we are going to see a hack for memory optimization. This hack belongs to how we can save memory while trying to search for a value in a set of values. We are going to see first what kind of solution we are trying to do, and then we are going to demonstrate how to implement it and save the memory footprint. So let's get right into it. So let's see the sample code. It works perfectly as it should. For example, for the pink, it's giving color doesn't exist, and for the black, it would give color exists, right? So, do you see any issue in this code? On the superficial level, it's not an issue, but do we actually require to provide extra space in terms of the boolean which we have provided for every value in the colors? So yeah, that is an issue, and let me demonstrate how it turns out to be a bigger problem when we have number of values and we do provide extra spaces. So let's jump to the demonstration part now. Let's try to demonstrate this on a map of, let's suppose, I think at least 1 or 10 million. That is when it's going to show us the real issues. You might say that that is a size which we are not going to encounter usually. So that's true, but I'm not saying in terms of only one map. This you can imagine that you have multiple maps in your application, and sooner or later, for some reason, you might see a spike, and you might see a lot of entries in memory, and that will create a problem somehow. I demonstrated this is because for demonstration purpose we are only utilizing a single map, and that is how we are going to do it. So let's suppose I have a memory usage function which is going to calculate the memory usage for us, and also let me just copy the code which I have already prepared for this. I'll walk through the code at what we are trying to do in this code. Okay, so first we are going to calculate the initial memory usage, which is being simply done from the runtime package. It provides some memstats, and from that we can read the memory. It gives the value in bytes, so we are first utilizing that. Then we are basically making a boolean map. Now this boolean map basically will create a map of size 10 million, and it will just simply create it and provide the key with the value just 2. We are also now then going to calculate the memory usage after the map was created, same by the memory usage, and then we are going to calculate the difference between them to check what was the actual memory increase when a map of such boolean case was created. Once that is done, we are going to free the memory by running the garbage collector and making the reference nil for the boolean map that is required to shoot down the memory to the lowest part, so that we can effectively get the next memory usage of a particular int map or any other. So that's what the same we are going to do with the int map. In this all simply we are just making a map of string int. The keys would be of string type and the values would be of int type. Usually the bool would take around 1 byte, and the map of int would take around 4 to 8 bytes depending on what kind of ints we are using. We are again going to run the garbage collector to free out this int map also. Now see what we are going to do here. We are utilizing a string key but with a struct kind of a value, empty struct. Why do we do that? So that is the main optimization we are trying to see here. When we pass an empty struct, Golang treats it as a 0 byte. That is the reason this whole optimization works. That is the reason the memory optimization works. That is the reason our memory doesn't get unnecessarily used. We are going to see how much does that make a difference. So just see here, just give me 1 second. I'll just put a bytes to MB function also. In this we are simply just changing the bytes value to a MB value, dividing it by 1024 multiplied by 1024. That's it. Okay. So let's see. For the map of bool value type, we are getting around this number of bytes as the memory usage. For the int, we are getting much more. For the struct, we are getting this much. Now you can see what the difference looks like. When you are utilizing a bool, it is, and struct, the difference is around 17 MB. You have saved 17. In terms of int, it has saved 136 MB memory of yours. That is how much you can save when your size is increasing. It looks like a small optimization, but it plays a very huge role in terms of the memory footprint you are leaving in your application. And this is the right way of utilizing the map for searching. And I hope that helps you, and I hope that you are going to use this optimization in your future projects. And do let me know if you have some other kind of memory optimization you do for searching purposes. And yeah, let's see you in the next video. Thanks for watching.